I mean, we get a lot of stuff from CSI exactly the same way because, for instance, right now they're switching from the individual Cisco gear to the Nexus platform. And so all of their 2,000, 3,000, 4,000, 7,000 gear is up and available. You know? So we're getting a lot of that through the door right now. Okay, dokie. First off, if you are in the job market or curious about the job market, we have a couple of our alumni who work at Caterpillar Financial. They've been visiting some classes. We'd lost enough time. I didn't want to do any more in here. But they're having a get-together from 4:30 to 6 this evening down in 237, which is the glass room all the way at the end of this hall, right off the patio. Caterpillar Finance hires a fair amount of our graduates. They like us. What they do. If you're going to buy a car, you're going to go, you're going to finance it probably through either the bank or GMAC or something like that. If you're going to buy one of those big yellow dirt movers or something, Caterpillar Finance is probably who you're going to do. With that kind of money, they have big security implementation. That's what a lot of our people do down there. And so be a good way to kind of find out what's going on in a company that really likes our program. They're based in Nashville. And to, kind of find out some information that you can't get from us. And you can believe most of what they tell you about me. So, okay, so last time we started looking at how SIP messaging works, and we kind of we've built the world over the last couple of times. We have that distributed architecture. We've defined the fact that SIP is a transaction-based protocol. In other words, it's based on I send you a message, you send me a message. We're both SIP entities. Last time we dug real deeply into some of the packets, and we looked at the big, long, weird-looking addresses. That's great for troubleshooting. We're actually going to continue to do some of that in the lab. But for an awful lot of what we talk about, this kind of detail is way more than we need to know. This is great if something's gone wrong. If you went back and looked at any of this, this is, I forget which packet this is. This one is, I think, nope, I don't have it on here. Anyway, this is one of the SIP registration packets. If it's not working, it makes sense to go this deep in there. And you may find, for example, that the registration message specified some wrong information or something like that. But for an awful lot of what we do, talking about what this stuff has to accomplish, or looking at your normal system operation, we don't need to go into that detail. You can always pull this up. And we, and like I said, we will some. So what we're going to take a look at is some stuff. If you've had 343, anybody in here not had 343? You're taking it now? Okay. If you've had 343, you've seen what I'm going to show you. You probably haven't heard it called the name that I'm going to use it. And what we're going to do is look at something called a transaction map. Now, when SIP talks about identities on the network, there are actually 3 levels of this that go on. They do tie back to some of that addressing we looked to, but let's give them a little more useful name than all that long stuff. URI we've already talked about. This is who you are. Notice there's nothing in there that talks about location. It says at domain. Yeah, but from a network point of view, domain doesn't really tell you specific network location. Domain is really more of a who, right? John J. Hart at Murray State. That's great. It knows where to get me. Now we've got 200 switches that you can choose from where I might be. So this is really all a who thing. For that reason, SIP uses something called a contact address. Contact address is who and where from a network point of view that you are. So I'm going to say I am John J. Hart at murraystate.edu. My contact address will be jhart at 192.168.8.21 or whatever my address is. I know it's 8 dot something. That tells the SIP server a much more useful address for me. Okay. This is typically the terminal that you register. Doesn't have to be, it typically is. Okay. This is one of the places a registration process can go wrong. Okay. The third one. So now we know who, and we know who and where in a form that we can use. The last one we're going to do is something called a media address. Now, remember, we actually haven't made it to making a call. Today we're going to talk about our first actual SIP call in from a signaling point of view. Media address is where I'm going to send that stream of coded audio. Now, in the example here, I show the media address as the same address in the contact. So in other words, I'm looking at I am this user at this domain. My location is, here I am, and I'm at this network location. Usually, not always, usually I'm going to send media to that same address. We'll get into the exceptions later. I wanted you to know that there were times when we would do that differently. For today, we're going to assume these two are the same. Okay? So, if you look at what I've got now, we've got who and where from a network point of view, and for this user, this is where I want you to send audio. So really 3 different ways of looking at this information. And the way we're going to use that, the way this all happens, let's take a look at that registration process that we talked about last time. We have a SIP server sitting in the middle. We have an endpoint. And the transaction that goes on between it, again, is a series of messages. So when I'm going to register as an endpoint, my user agent client is going to initiate that process. At this point, we're assuming that whatever device I'm using for my phone, either a soft phone or a hard phone, already has an IP address and has already been configured with enough information to know where the SIP server is. Obviously, we have some differences in that, and we'll look at them in the lab this week. My user agent client at the endpoint is going to send a message to the SIP server, and the message is going to use the method register. Basically, it's going to say, hey, here I am. Okay, look at what's happening here. There's an endpoint on the network. I'm going to send IP traffic to an IP address. The server then has information we need. I'm going to send it who I am. I'm going to send it my contact information. So now the server knows who I say I am and knows where I am on the network. Okay? What's the problem? So do we just come up at this point and everything's good? Think about it from a security point of view. Have I proven anything to you? No, I've just said, this is who I am. Any good server is, of course, going to say, malarkey. Choose whatever expletive you like. You're not authorized. You need to prove to me who you are. And so I'm going to respond with whatever we've done ahead of time. Most SIP installations will use username and a password. That's the automatic that you put in when you built accounts. You defined the user as the phone number. Remember, our format that we're using in class, and most places use, is a phone number at a domain. In this particular lab, I'm just using IP. I don't want to muddle things with DNS right now. But you have a password on those machines. Now, so far, you've only used the default password, which is 1234, real secure. One of the problems we have with later labs is the newer software for the soft phones generates this long, random password. Great for real installations. It's going to be a serious pain in here to deal with, and I haven't quite figured out exactly how to do it. So anyway, I say, here I am. You say, prove it. I send a message back saying, this is my user information, and here is my password. This is the one thing I should know that nobody else should know. Okay? Assuming the server gets a correct answer on that, it's going to enter my contact information. This user is at this network location. It's going to put that in its database. And you saw that, remember? When you went back and looked at your user accounts, once they had registered, it would tell you what IP they were on. That's the process you've got here. At that point, look at the situation we have. The server knows where that endpoint is. And the endpoint knows how to contact the server. So in other words, we have effectively a point-to-point connection. Doesn't actually operate that way in the physical world, but that's what it looks like, because server, client are aware of each other as the opposite ends of a transaction. Okay? That ought to be pretty familiar. So let's go ahead and take a look at what happens when we're going to do a call. In this case, we're going to expand our world a little bit. We'll have a SIP server with a few endpoints. We've got a few players in this. We're going to say that there's John, and I'm going to go through that same registration process. So I'll register, get the challenge back from the server, send back the answer. Assuming it's good, I get an OK back from the server. And the server has entered my information, my contact information, essentially my name and address in its database. All the other users on the network are going to do the same thing. They'll go through the same registration process, and they'll end up in the database. I couldn't do this in one side, so I put Alice over on the other side. You can't have a network discussion without Bob and Alice. They show up in every book. I don't know who invented them. So we're going to do this for every device. What we end up with, of course, is a list of active SIP clients on the network. Now let's stop before we go any further and think about some places where this might blow up. So far, I'm showing everything on a single subnet. I'm showing everything. I haven't really shown you a physical world. This is a pretty simple place. This is basically what we have in the lab right now. Everything's on one network, on one device. When we start moving this out in the world, what kind of problems can we run into? I'm sorry? How would that happen? In other words, I might somehow this string user at domain is not unique to me.
Maybe you have somebody, maybe you have two people with the same name on the network, and somebody mistakenly put
Okay.
it in, so they log in with the same person.
Okay. You could, if you're using usernames, that's the same thing. That's not actually a SIP problem. That's just a like a Active Directory problem or something like that. You have to have unique usernames. In our world, as I said, normally you're going to use phone numbers for that, and so your users are going to reflect your dial plan, and they'll be unique in that. You could end up with that. What happens if I don't have a local network relationship between all of these? How does that complicate things?
Then you have to go to the internet cloud to get to them, and it could be congestion in the cloud or problems with the actual physical media to get it there.
I'm going to go about halfway to what you said. Let's wait for a second before we bring the internet in. Let's put it outside our local network, but on another local network. What does that do to me? It introduces one device. It introduces a router. Right. So now, I've got a problem assuming all my layer 3 connectivity works. We'll assume that IP works. And one of the things you're going to learn as we design things is get layer 2 working, then get layer 3 working before you ever worry about dial plan or anything like that. Get your network working. Okay. If I have a router inserted in the middle of this, I have to be very certain that it is aware that I'm passing SIP traffic. Now, a router, by default, won't care. Firewalls will, and firewalls, a lot of times nowadays, will actively talk to routers and make changes. So you have to be sure that the world is aware, the world of your network is aware that you're passing IP traffic. We also have to avoid that issue I showed you the other day where you have signaling media. That's what we're talking about here, right? We haven't done anything with audio yet. We have signaling passing, and then we have audio passing. Now I have to be sure that the audio can get where it's supposed to go. We'll come back to that here in a minute. If we extend this past our larger network and out over the internet, we run into a couple problems. What are the two things I said voice is highly sensitive to in terms of voice over IP? Latency and?
Drop packets?
Well, yes, it is drop packets. We lose data. Jitter was the term I used. Latency is delay from the time I start a packet till the time it's delivered. So delay across the network. Jitter is variation in that latency. And voice doesn't like no real-time application likes either of those. In our case, it's because we have humans on the end. I don't like delay, but I'll deal with it to a certain point. If you make me have delay, and you cannot avoid it, and you can't avoid it in any electronic network, you really can't avoid it in a packet network because of processing delay. If I'm going to have delay, I want it to stay the same. I don't want it to be jumping around between times. I want the delay between when I say something and you hear it to be predictable. I want it to be the same throughout a call. Okay. We'll talk about how we address those, but the short version is the schemes that we use to do that do not cross the public internet. They stop at the public internet edge. So one of the problems people will run into is they will they'll build their local network, may even extend it on their private network to other sites. It's your private network. You can control that stuff. If they try to add a hop across the internet, all of a sudden things stop working. We get tons of jitter, we get lots of drop packets, we get long delays. It's because all of those controls we put in place are simply discarded at our ISP's edge router. Okay, so we have to remember that. We'll talk about that more when we get in towards that part of the class. Okay, so at this point, we have 3 users registered with the SIP server, and we're going to make a call. Let's say John's going to call Alice. You've made calls in here, and it happens, pretty quick. You dial the numbers, up they come. There's a fair amount that goes on before you do. Remember that SIP is a signaling protocol. SIP does not transport audio. It controls the transport of audio, but it doesn't transport audio. Okay, that's the job of the codec. We'll talk about that later. There are reasons you need to make choices in codecs. SIP controls the call. So our traffic's going to look like this. We're going to start, and we use a method called invite. And notice what happens. From my endpoint, I'm going to make an invite, but I'm going to send that invite not to Alice's machine. I'm going to send it to the server. Now I'm going to specify that I am inviting Alice into a call, but I'm going to send it to the SIP server. The SIP server, first off, is going to see if Alice is available. What happens if I try to call Alice and she's not registered with the system? Yeah. And at that point, we'll get an error message basically saying, we can't deliver this call. Why? Because the endpoint's not there. If Alice's endpoint is known to the network, just not active, we'll get one message. If I'm trying to call somebody that doesn't exist, I'll get a different message. You see both of those. In this case, we'll assume that Alice exists on the network and is registered. So she's there and available. What happens is the SIP server turns around. Which user agent did this? Why? You're exactly right. Why do you say that?
Why do I say it?
Yeah. Why, how did you know it was a user agent client?
Because the way you described it is user agent client to the server, and then the server becomes a user agent client going to the endpoint.
You actually jumped ahead of me a little bit. Yeah. User agent client makes requests. Okay, and that's what we're doing. We've done a request that is an invite. Where's the user agent server? The SIP server. Okay, now, where's the SIP server is going to reply to that request. Now, it can't do anything yet, but what it's going to do is send me back a status message, one of those 100 messages. It's going to say trying. Yeah, I'm working on it. Stay tuned. Okay, this is the equivalent of when you pick up a phone and dial and you hear a ringtone in your ear. That's the equivalent of this. It's saying the network's not broken. We're working on it. Okay, that's what trying means. The next thing that happens is the SIP server is going to turn around and it's going to issue a request. So it's going to be what type of client? I just gave it away. What type of user agent? User agent client, right? Because it is issuing the request. So even though the name is server, it's acting as a client. Okay? It's going to issue an invite to the other endpoint. The other endpoint is acting as a user agent server in that case. And therefore, we'll do what with that request? Issue a response. Exactly right. So the response is trying. Don't worry, we're trying to get there. Okay. And then it's going to say ringing. What's the difference between trying and ringing? Trying is meant for the other end. Trying is letting me know the network is doing what it's supposed to be doing. Ringing is telling you that I'm actually alerting the other end. And in fact, in a lot of protocols, ringing is called alerting. I'm telling your phone to turn on its ringtone. You know, so you're going to hear whatever you use for a ringtone. The server is going to pass that message back to the original, to me, to the original client. So I'm going to know that your phone is ringing. Why would that be important for me to know? Is there anything else that could happen that we wouldn't assume it would be ringing? I'm sorry? Why would it go to voicemail? Already on the line, right. What if I did this call setup and the Alice was on the phone but didn't have it set to go to voicemail? What's the situation there? What would I have to tell the original end, me? Yeah, it's busy. So I'll get a status message that tells that. In other words, there are a lot of possibilities in here.
And is call waiting just the ringing coming back?
Call waiting is surprisingly complex. What call waiting will do is say ringing to you, and depending on how the user configures interrupt status, it might forward to voicemail, it might ring busy back to you after a minute, it might ring on through. Because I can do lots of things with call waiting, right? I can choose to answer it, I can choose to ignore it, or I can have it go to voicemail after 3 rings. So depending on what happens in there, I'm going to get one or more messages sent back across the network for status. Okay. We've mentioned voicemail a couple times. I hadn't actually intended on dealing with this in here, but let me run with it. If we have that situation, we call across here, Alice is on the phone, and she has it set for her phone to go to voicemail, what have we changed? From the initial setup that I tried, what have we changed?
We redirected it to a different location.
And you use the magic word. We have changed where that call is going to go. We have it, it's not busy. Alice is busy, but we want the call to be delivered. Remember when we talked about applications? And we said in this class an application is what you do with a call. Okay. One application is we can deliver that call to Alice. Well, if she's on the phone, I can't do that. So another application is I can change the destination of that call to voicemail. I do that through a method called redirect, which we'll look at a little later. But yeah, basically the server takes that invite and points it at Alice's voicemail, which is actually another endpoint.
So
Okay.
would a busy come back from Alice to the server, and then the server would...
In most cases, no. In most cases, you'll get a ring, one or two rings, and then it will redirect to voicemail, and it just goes through as a completing call.
From Alice it redirects, or just go back to the server?
Well, what'll happen is you get the invite, server says trying, the server turns around and issues the invite. At that point, server gets the invite, you get the trying back. The server knows Alice is in a call, right? Because it's in the middle of all signaling. And the server will have been told by Alice or by the administrator what to do in the case that Alice's line is busy and receives an incoming call. And in that case, the server will issue an invite to voicemail. It delivers it as if it's a call. It just changes the destination of the call. All of these things, this is what I meant the other day when I said that all of those methods are really pretty simple things, but you can stack them up into pretty complex responses to a call. If you've ever dug into asterisk, all those little scripts you write for asterisk do exactly that. What you're doing is writing a little program that says, if you see this number come in, do this with it. And one of the first things you say is, answer the line. And you go on. It's a branching tree for what you do with a call. In this case, we've issued an invite. The server has said we're trying. It has reissued the invite to Alice that I'm trying to call. Alice, acting as a user agent server, has issued a trying and has issued a ringing. The server pushes ringing back across. It had already given me a trying. Okay. So now at this point, Alice's phone is ringing. I'm hanging on, listening to it. Whatever we feed, usually it's a ringtone in my ear. If Alice picks up the phone, her endpoint then issues an OK. An OK. OK for what? We've had an invite. Now she's saying, yes, I will accept this. Okay. So we get OK. The server passes that back. Notice the server is in the middle of all of this signaling. Always. Nothing has gone end to end yet. Okay. Okay. Now we set up ACK. Why would you have my end acknowledge that?
In case you hang up during an
Yeah. In case I change my mind and I don't want to talk to Alice. Okay. Or in case some other circumstances come up on my end. Maybe I've got another call coming in. Okay. So I'm going to acknowledge it. I'm actually acknowledging the OK because what the OK says is, yes, we'll accept the call, and I'm acknowledging it, OK, you're going to accept my call. Okay. We pass the ACK back over. Now what do you think needs to happen? What's the situation on the endpoints? Yeah. From a person on each end of this line, I've dialed, I've been listening to this ring. It has stopped ringing. Alice has picked up the end and has the phone to her ear, so we need to pass audio. At this point, there's actually some transaction that goes on in between here we'll look at a little later. I've shorthanded it into showing a real-time protocol media stream. What we actually do in here is negotiate where what address I need to send my audio to for Alice to hear it, and what address Alice needs to send audio to for me to hear it. What was that address? We gave it a name. Contact address is where I am for signaling. Media address, right. Now, we also noted that normally they're the same. They don't have to be, but normally they're the same address. Okay. So, now we're passing audio back and forth. And that little piece right there is where we get in trouble with firewalls. If you assume that the firewalls that Alice is on a different network, that's actually not the way I addressed it, but let's say for a second Alice is on a different network and there's a firewall right here. All of this traffic was initiated from the server towards Alice, right? So any responses coming back are tied to that. Look at this. This was initiated, well, the way I've got it drawn, it would actually work. But what about this stream? What does this look like to a firewall? It's not tied to anything we've seen before, because that's a completely different discussion, completely different conversation. The firewall is going to say, we didn't ask for that. Go away. It's just going to discard it. One of the most common failure things you see is one-way audio. And it's almost always a firewall sitting in the middle of that stream that sees one direction of the audio as untrusted and discards it. Okay? There are ways to deal with it. It's always messy. Now, let me stop a second. What happens if I have, let's say the outside edge here is a router that's facing a wide area net, and I'm doing NAT. What have I done to my traffic? What does NAT do? Yeah. I have an internal set of addressing that I don't want you to see, or that is unroutable on the internet if I'm using private range addressing. And so I've got addressing set up on layer 3 going to an endpoint, and all of a sudden I've just changed the addressing. And you can get into issues that way. Part of what goes on is whether intermediate devices are smart enough to look deep into the packet. If they can only look at layer 3, and that's as far as they look, read router, then that's going to break SIP, because SIP operates at an upper level. Okay, and although the address that SIP intends you to see is actually buried in that packet, it's there, you can set up a situation where it's not accessible to SIP. And NAT is one of the things that does that pretty regularly. So there are actually specific tricks you have to use to get around NAT. Okay?
Does RTP stand for the
Real-time protocol. We'll talk about it more later. Basically, it's a streaming protocol. When you stream video off the internet or audio off the internet, odds are you're using RTP. There are other ones out there, but it's far and away the most common. There's a related protocol called real-time control protocol, which we'll talk about a little later. It's actually cleverly named RTCP controls the setup and management of RTP. Gee, go figure. So we'll talk about those later. Okay, when we're through talking, one end will decide to hang up. In this case, let's say I decide to end the call, so I hang up my phone. The effect on that from my endpoint is that I issue a SIP method called bye. What I'm saying is we have an established connection and we're through with it. I want to tear this down. Look at everything we've built up. We've got a fair amount of stuff to take apart here. I've got to take the RTP streams down, both directions. I've got to deal with anything that's monitoring this traffic, which I didn't even mention going through this. You can actually have other devices monitoring this. For example, have you ever seen an operator's console that when somebody in an office down the hall is on the phone, you see a light on that console? Used to be done with a pair of wires. Now we do it by repeating SIP traffic into that console and having it turn on a light. So we've got a lot of things like that going on. But anyway, BY initiates tearing down this whole world we've built. Again, I, as a UAC, issue a request using the method BY. The server takes that, turns it around, says BY to the endpoint. We get an OK from the endpoint. The server gets an OK back to me, and everything's torn down. Now we're back where we started. I am on the network. I am known by name and location to the SIP server, but I'm not in a call. Alice is known to the SIP server by name and location, but is not in a call. So we're ready for this whole process to start over. Okay. This is a very basic call. We mentioned a lot of ways that we could branch out of this, and that's really the hard part of dealing with this, is realizing that simple calls like this may be the bulk of what we do, but they're by no means the only way things can happen. We already mentioned what happens if it's busy. We can send it to voicemail. We can busy it out. We can do something like that. What happens if we do three-way calling, as in conference call? Now we got a weird one. I've got signaling going multiple places. I have multiple RTP streams, but they're all starting from the same place. Okay. Let me ask this. Is there anything about this that limits this to audio? What are we really saying with SIP? We're saying this user is here on the network. This is the location, and this is that endpoint's status. It can accept calls, it can't. If you'll recall from yesterday, or 2 days ago, one of the things we said in that setup packet was capability. There's actually nothing that limits this to voice, and a lot of the video applications you see are SIP. What's the difference? RTP is going to be a lot bigger stream. That's it. Why? Because I'm coding video, which takes more bandwidth to code than audio. So I can use this for anything that's real-time data. That's one of the reasons it's caught on so much, is you have a very flexible infrastructure that's actually pretty lightweight. I mean, you can, even just reading the raw traffic, you can follow what's going on pretty easily. You know, you don't have to translate a lot of this stuff. It helps sometimes, but you don't have to. Now, I'm sorry.
Shut down the RTP stream as well.
Yeah. Yeah. BY is kind of a linchpin. Okay, what you're saying is, I wish, you can read this another way. I'm through, take this apart. So I tell the server, take my part down, and the server then says, BY, we're going to take this down. Okay, okay.
Yeah, but the server has nothing to do with the RTP.
The server is in the middle of the signaling that controls the RTP streams. So if I say this call is over, I don't need the RTP streams anymore. And that's where the user agent server at the far end comes in. BY is a request. If I'm saying BY, the user agent server is going to say, okay, well, I don't need these RTP streams anymore. Down they go. Okay. Now, speaking of RTP streams, what happens if I have more than one call leaving a site? How do I keep streams straight?
I put them on their own channel. Or,
okay. In a TCP IP stack world, how do we separate conversations between the same IP address? That's a layer 2 problem. It doesn't know anything about IP. What level of the OSI model deals with session control? Session layer is 1, yeah. So we're going to control that at the session layer. So in other words, the session layer is going to monitor whether these streams need to be there. To separate individual calls, what we're going to do is have the session layer control the layer 4, the transport layer, port. We're going to put each of these streams on a different TCP or usually UDP port. Okay. Why would I use UDP for media streams?
You don't have to have every bit of data exact. You can use a pixel here on a video or a little bit of it all.
Sure.
It'll be okay.
Okay.
You can deal with a little static on the audio, that sort of thing.
Well, let me ask you this. If I have packets coming at you describing audio, and let's say that each packet, just for discussion, I'm going to put this in a little bit of a ridiculous world. Let's say each packet describes one word. Okay? So you send 30 packets, or I send you 30 packets, 30 words, and number 17 was wrong. In TCP, first off, you're not going to get 18 until you get 17 right. But since in some cases I can actually send packets ahead, how good is it going to be for you to get word 17 after you've already built up to word 32 or whatever number I used? You see what I'm saying? It doesn't help to fill in out of point. And that end-to-end acknowledgement per packet takes a huge amount of bandwidth and a lot of time, which means high. Sorry, I get all choked up talking about this stuff. Yeah, we have high latency on that, and we don't need that overhead. It's better for us if we simply lose a packet. We'll talk about this in depth when we talk about codecs, but basically the choice you make is how small a slice of audio am I going to take, and how often am I going to send that. You have to add whatever your transport overhead is, you have to add that to every single packet. Adds up in a hurry. In fact, when I show you the chart, what you'll see is you can easily end up with 2/3 of your bandwidth being overhead for 1/3 of it being audio. That's not a good situation. So, you're absolutely right. I turned a nice, short, to-the-point explanation to something long and windy, but you're exactly right. You okay with this? My main goal in this was two things. Let you see this transaction-based world and let you see that signaling always passes through the server. Media passes end to end. That's a point we're going to revisit several times. Okay. I'll go ahead and post this. On Friday, we're going to do some lecturing here. Then we'll start in the lab. Actually, I'll outline a lab for you, and you'll do it on your own. Basically, you're going to look at, basically you're going to look at packet traffic for registering systems and making a couple of calls. Okay. See you guys.